Okay, I thought that maybe I'd help you get a good start on this homework assignment since definition of derivative is still a little bit new. So I thought maybe I would do a couple with you. Now we already did one in class today, so maybe let's take a look at number 6 here, okay? Now notice in number 6, they give you the traditional definition. So from this, we have to be able to find the alternative definition and the function and the value where the limit is being evaluated at. Well, I know that the traditional definition says that it's the limit as h approaches 0 of f of c plus h. So we can see here that the value of c is 5. Now the next thing we have to do is figure out, well, what is this function? Well, we know that we replace x with 5 plus h. So we can see in the numerator, it's quantity 5 plus h squared. So therefore, it's going to be x squared. And then it's minus the quantity 5 plus x. Well, then that would be minus x. So the function is x squared minus x, and we're finding the derivative at 5. Now let's check, because if we've done this correctly, then f at 5 will be equal to 20. So 5 squared minus 5, 25 minus 5 is 20. So yes, we got it. So now that we know the function and we know the value that I'm finding the derivative at, I can do the alternate definition. So the alternate definition is we're going to approach, my writing is horrible. The limit as x approaches c. And in the numerator we go f of x, which is x squared minus x, f of x minus f at minus c, or is that f of c? Oh dear, it's f of c. So f of c is 20, because when I substitute 5 into the function, I get 20. And then it's all over x minus c, which would be x minus 5. So that would be the alternate definition. Now you're going to have to complete the rest. But let's go to the back page. So not actually the rest, just the rest on this page. Okay, so on the back page, I thought I would do one of these with you. And I'm going to do the one that had a typing error. Okay, and good job to Annie because she pointed it out. So actually the second one, there is a typing error. It should be a, oh, I changed it on here, but not in your document. There should be a plus sign between these two binomials. So that should be a plus sign. Okay, so let's go ahead and find this limit. So it's as h approaches 0. Well, first thing I have to do is I have to expand the numerator. So the limit as h approaches 0. Now I'm going to have to write big because otherwise this pen doesn't work. You know, maybe I'll make the pen a little bit thicker. Maybe that will help. Let's see. Okay, so now we're going to expand. So I have x squared plus 2hx plus h squared. Now I'm going to distribute the 3 plus 3x plus 3h minus 2, and I'm going to distribute the negative minus x squared minus 3x plus 2, and then that's all over h. Now don't freak out, we're going to combine like terms, okay? So let's see, we've got an x squared minus an x squared. Beautiful, those cancel out. We have a 3x minus a 3x. Great, those cancel out. And then we have a minus 2 and a plus 2. Fantastic. So all of those terms cancel out. So we are left with 2hx plus h squared plus 3h. And that's it, all over h. And it's always keep writing this, the limit as h approaches 0. You need to write that every single time, otherwise you'll get docked points. So now let us reduce, because I noticed that there is an h in common in the numerator and denominator. So if I reduce out the h, we end up with 2x plus h plus 3. And let's evaluate it where h approaches 0. So we end up with the derivative function is 2x plus 3. And this will be able to tell us then the derivative at any value x. Now you complete the rest of the worksheet.